A tray of corn muffins requires 4 cups of milk and 3 cups of wheat flour. A tray of bran muffins takes 2 cups of milk and 3 cups of wheat flour. There are 16 milk and 15 cups of wheat flour available. The baker makes $3 profit per tray of corn muffins and $2 profit per tray of bran muffins. How many trays of each should he make in order to maximize profit? This is a linear programming problem, and you can tell by all the information we're given where there's lots of things to follow and different amounts to create inequalities for. So we need to identify what our objectives and our variables and our constraints are. So first of all, let's talk about our objective. Of course, this baker wants to make profit, so that's our objective in orange. Our variables are always two things. So in this case, we're talking about corn muffins and bran muffins. Constraints are oftentimes limitations, but they can also be something that you want more than. For example, the nutrients with the astronauts. So in this case, we're going to be limited by the amount of milk and the amount of wheat flour that we have. So when it comes to organizing this, I like to use a table. I'm going to put my two variables, corn muffins and bran muffins, on the top. And then I'm going to list my constraints, which are milk and wheat flour. So flour. We also have some numbers about their profits. Now I'll just use the information. Corn muffins take 4 cups of milk and 3 cups of wheat flour. Bran muffins take 2 cups of milk and 3 cups of wheat flour. Our profit for each corn muffin is $3, and the profit for each bran muffin is $2. Now, I'm going to go in alphabetical order, so I'm going to call X my bran muffins and Y my corn muffins. That way, when I'm graphing them, I can stay consistent. You can use B and C if you like. I'm going to stick with X and Y. So I need to make an inequality for some of these. Now, remember, profit is our objective function, so that one won't have an inequality. That's just going to be equals. Let's talk about our limitations. Milk, we are limited by 16 cups. Wheat flour, we are limited by 15 cups. And profit, we don't have a max or min. We just want to see what we can make. So if I were to make an inequality for milk, again, that's a constraint, a limitation. I'm going to say 2x, because 2 for each bran muffin, plus 4y, must be less than or equal to 16, since that's the amount of milk they need. Then for the wheat flour, 3 for each. So my equation follows 3 times each bran muffin x plus 3 times each corn muffin y must be less than or equal to 15. Now my profit equation, I'll write up here because that's my objective. 2 times x, so $2 for every bran muffin plus 3 times y. I'll use that when I'm done to see what combination makes me the most profit. Now, you could guess different amounts of bran muffins and corn muffins to see where you'd make the most money. But we have found that if you can graph these constraints, you will be able to shade the feasible, not shade the non-feasible region. Remember, on linear programming, we shade away from our solutions that work. So let me pull up a graph here. I have graphed both of these. Now, if you'll look at previous videos, you'll see how we would graph inequalities. We've done that a lot. Here I have bran muffins on the x-axis and corn muffins on the y-axis, right? And again, my intercepts here. I happen to know this black line here is all about my wheat flour. So if I was going to plug in 0, 0, of course I would be under my wheat flour, but I'm going to black out away from these lines because I can't make more than that or I'd run out of milk. So let's try that again. So I'm going to color out there for that black line, and then of course out here for the green line. Can't make more than the amount of milk and flour I have. So my feasible region is this zone right in here that's bounded by this circle right here, this intersection point right there, and this place right here. Now 0, 0 is also corner of my feasible region. Okay, this is all not feasible out here. These 4 test points, well technically 3, because making no muffins will make me no money. These are the only 3 points I need to test. So this coordinate down here is 5, 0, 5 bran, no corn. This coordinate right here is 2, 2, 3, sorry, I cut my scale off there, graph yours carefully, 2 bran, 3 corn muffins, and this one is 0 corn muffins, sorry, 0 bran muffins, 5 corn muffins. The only 3 points I need to test are these 3 in my profit equation. Now, remember, we make more money off of a corn muffin, so I'm going to test this one. I'm not going to worry about testing bran muffins because 5 at $2 a piece is not going to make me as much as 5 at $3 a piece. So if I told no bran muffins, 2 times 0 and 3 times 5, I will make a total of $15. That is my profit for this top point at 0.5. If I were to sell 2 bran muffins and 3 corn muffins, I would make $9 plus $4, and that would make $13. So out of those 2, the amount of money that I make the most at appears to be at the 0.5. So we can conclude that we would make the most money by selling 0 bran muffins and 5 corn muffins. Now, if you watched this whole video, you can add Go Rockies to the top of your test and earn 1 extra credit point.